we ended up buying over a 10-year period, acquiring, doing private equity deals and buying 5 businesses.
Welcome to the Cowles Ventures Podcast.
Ready to get rolling?
Sure.
Okay. Well, yeah, if you just want to start, brief background, and then we can kind of dig into it. I mean, you've had a very successful, very awesome, fun career, and I feel like you don't get to tell that story enough. So I'm excited to learn all about it. We don't have to go too into detail on too much of anything, but yeah, I mean, where'd you come from? Where'd you get your start? Obviously, now you're working on something very different than kind of in previous times, so we'll get into that. But
I started to frame. I have a lot of range.
You do have a wide range,
right?
Yeah.
And started out as a farm kid, and but we got to travel the world because my dad was marketing all the grain grown in the Pacific Northwest. 95% of it's exported. So we were in Tokyo and Hong Kong and Taipei and Seoul. I got to go all over the world, DC, and always yearned for the farm. We'd come home.
Yearned for the farm.
Well, it was my awesome. Grandparents had it's tractors and running the equipment.
And
stuff
when you're
like
a kid, oh my God, I just want to do something.
So finally in junior high, we moved back to a big ranch, and so I say I made it through engineering school because I broke everything on the farm and the ranch. Had to fix everything. So and I like doing that, and I designed and built a 30-foot gooseneck tilting trailer. My junior year in high school, and I got to do we had a really good FFA shop program, Future Farmers of America, and we learned to do surveying and concrete work and plumbing, electrical work, and making machine tools and welding, and then I just designed this trailer, and the instructor said, "Sure, you can build it," and he just gave me the keys to the shop. So it was a 2-hour shop class, and then I had the end of the day. So I spent 3 more hours every day and built that. And it made $1,000 when I sold it.
There you go.
Yeah.
It's a lot when you're in high school.
Right. And way back then, too.
I mean, yeah, seriously.
In the 70s. So that was a lot of fun. And farming was really tough in the 70s going into the 80s. And I wanted to stay and farm and that kind of stuff. But I liked engineering too, so I went off to be a mechanical engineer and started at Hughes Aircraft. Now it's Raytheon.
Okay.
And their missile systems group in Tucson, Arizona, as a process engineer. And so there were semiconductor packaging. They were making semiconductors. We had circuit board fab, circuit board assembly, optical, IR, seeker head, optics, electromechanical. So you get to work across all that stuff. Process engineers setting up processes around electronic manufacturing. So that was a lot of fun, and ended up getting married and going to Seattle because that's where she was going to go to law school, and landed a job in R&D at Boeing, doing similar kind of stuff in defense and space. Okay. And it was fun, and it was really a good learning experience. At Hughes, there were some really good guys, and kind of start to set a basis around quality management systems, and it was a body of knowledge of a certified quality engineer. There was a couple guys kind of pushing just understanding process control based off those fundamentals, and using statistics and stuff. And then at Boeing, I got a lot more of that and found a group down in the fab division, Auburn. So they were making wing skins and all the composite parts and stow bins. And it was 10,000 people, all these different divisions down there. And I was basically a black belt Six Sigma engineer, going and helping different divisions problem solve. Again, process engineer, collecting all this data, helping them sift through the data, applying statistical process control and design of experiments to dial in manufacturing processes. So that was a lot of fun, but I wanted to do more.
Yeah.
And I had a really great boss, and he was super supportive, and we were so progressive in his group that he had built and set up But I said, I'm going to go do automotive. And so in the early 90s, we packed up and moved to Michigan. And I was supplying parts into Honda, Ford, Mazda, Mercedes, Volvo were my main, a little bit into Toyota stuff. But it was all around the Toyota production system principles. And our plant was growing so fast, we had everybody coming to see what we're doing. We had 3 or 4 book authors show up. Jeffrey Liker, Becoming Lean the Toyota Way. We were featured in about 5 books, and it was a blast. And it was so much more responsibility than just like at Boeing or Hughes. Hughes had some really good principles around process instruction, and they had really good infrastructure built. So that was a role model I've always kept in my head. And Boeing, it was just so big, you didn't see the dollars and cents. And at Donnelly Corporation, I could call up a temp agency and say, I need 10 people at the gate at the Ford plant for this launch tonight. And we would fix parts all night long if we found a problem. Yeah. And no one ever asked me, well, who authorized you to do that? We were expected just to do it, get it done, get it fixed. Right. And that's a little bit smaller. It was still a big company, but it was smaller teams. You were given a ton of responsibility and you just executed. And that was a lot of fun. But I was in advanced product development there, and my old Boeing boss kept calling me, come back. We were trying to do the lean stuff. And I said, and he says, well, there's this consulting firm that has a contract with us, and they're looking for you guys. It's called Delta Point. So I went. I was tired of the Midwest humidity and missed the Pacific Northwest. So we moved back and ended up in Spokane because we have a family farm down by Walla Walla. Never really spent time in Spokane, but it was close enough where I can catch easy flights and then be close to the farm and stuff like that. And so I came back and I went to work, and I traveled all over the country in the mid-90s fixing Boeing supply problems and training Boeing people would go with me. And I knew how bad the problem was based upon the level of manager coming, a VP, director, manager, supervisor, so it was everything from windshield wipers, landing gear, seats, pitot tubes, U-picket. I was a titanium mill, aluminum mills, lots of machine shops. And basically I was going in and helping do turnarounds with these companies. A machine shop in Canoga Park, California, LA, in 1 week we did a 1,500% productivity gain on one of their product lines. Jeez. 12 months later, they got a $65 million contract from Boeing. They were only $3 million in sales.
Oh my gosh!
When I started working with them.
They're like, thank you guys so much for coming and fixing all that.
And Boeing paid for me to be there. So,
that is crazy.
So it was just a lot of those over and over and over again, and that was a lot of fun. And I started by 2000. There were some changes going on with the company. My dad got sick, passed away, and I kind of stepped in and took over forestry stuff. He had a timber management company. Okay. So did a lot of that for a couple years, but I still had a lot of old clients calling, hey, come and help us. And then I started building a network here, not really too hard. Neighbors would say to another neighbor, hey, you're adding your building on the Chris Wood does, So I ended up growing a pretty good base of clients here in Spokane. Nice. Altec way back in the 90s. Kimball, I had done some work with them when it was Kimball or Harper's, the furniture guys.
And this is all in like process management?
Well, stuff? Lean implementation operations, And then Ecolite Manufacturing, Sour Slurry Pies, and then McKay Manufacturing. Okay. And then Purcell Systems, when they were just getting started with their cell tower boxes, set up their plant and really got them ripping. So those were fun. Yeah. And in that process, partnered with a guy, did a lot of work for Washington Trust and in their back office and stuff. And so they'd get people wanting to come back to Spokane. Hey, I'm moving back. And one of the guys had been in a Harvard MBA, and he was looking at buying a business in the area. And the guys at Washington Trust say, talk to Chris Wood. He knows a lot of the businesses. And this guy says, oh, you're doing what one of my classmates is trying to do. And this guy had set up a search fund, and he was looking to buy little businesses and stuff. So we got hooked up, and we ended up buying, over a 10-year period, acquiring, doing private equity deals and buying 5 businesses. That was a really interesting process through the journey. And along the way, there were some startups I helped. Green Volts was a solar startup down in California, but it was Ecolite had worked with them very closely, and Avista had worked with them closely, helping like Purcell Systems get started. They were a startup. And then there was a inverter startup for solar in Bend, Oregon. PV Power did a lot of work with them. So I kind of got to see a lot of the growing pains from startups to smaller businesses like that aerospace machine shop. They'd been around for a long time. Boeing had been a big supplier, and then the Boeings and the Goodrich and Allied Signal, or now it's Honeywell. So worked with a lot of different companies, and there's always an adjustment in them all. But that's been kind of my journey. And then I was poking around, playing with some ag stuff. My family has a big farm. I still like farming, and was teaching at Gonzaga, and COVID hits, and I like, what am I gonna do? Because we didn't know. Everyone's twiddling their thumbs, right? Yeah. A couple months there is like everyone just kind of stayed at home.
Yeah, I know, it's crazy to look back on that, and you can really tell the people that took that as an opportunity to kind of work on something crazy, and the people that were just kind of like, oh, like, I don't know, like, what do we do? They're like looking around, they're like, what the heck? And it's like, it's weird. I'm sure there's going to be some, or maybe there already is, documentary, some case study on like
people talking about what they did or didn't do.
Like trajectories of people's lives drastically changed, I would imagine, in that. But anyway.
Yeah. So I ended up getting contacted by Skywalker Holdings, and it was kind of this weird, I'm trying to look it up. You can't really find out much about them. It's like, well, they have a bunch of property. They said they needed a plant manager to make a composite facade stuff. So I talked to them, and they said, well, it's an 18-month position, and we want you to go direct. And I haven't been direct for, I've always just had to pay my own way, turn over my own rocks. I'm going, COVID, health insurance, vacation, holidays. Sure. And so I get down there, and it's a challenge. Yeah. So it's the job is to make the facade for the Lucas Museum of Narrative Art, and it's an incredible building. You can see all kinds of videos on YouTube where people have been flying their drones as it's been built and stuff like that. Well, I basically finished our last bit of work December 15th of this year. So it was over almost 6 years.
Yeah, right? A little bit more than an 18-month contract.
Right. But it was an incredible journey. There was so much engineering stuff to dive into and deal with that they hadn't considered. The company that got the contract, they had some NFPA, National Fire Protection Association. They'd passed the burn test and stuff like that, but then they hadn't figured out everything else necessarily, and the volume to ramp up. And so it was a big challenge, and I liked it. It was fun. Yeah. And there's so many dynamics because there's a frame that each panel gets mounted on, and that was produced by someone else and engineered by someone else. But the two groups were supposed to work together. And when I got there, they were already fighting and playing
His
games.
problem.
Right.
My fault. Yeah.
And it was so weird. I'm like, is this some movie? Is Truman gonna walk through here or something? But we got through it all, and so there were a lot of constraints I had to work within, but figured it out and ramped it up and got everything built, and
that's awesome.
Got people trained. So now I have one last little thing to finish.
Yeah. With them.
Yeah.
Yeah.
On the way, my boss said, "Oh, I got one more thing. You can paint. You can paint things, right? Go rent another building." And we were like, "What? Oh, I have this movie prop you need to take care of. What is it? It's a starfighter. It's 35 feet long and 25 feet wide.
Just a little project. Yeah. It's nothing big.
Yeah, restore it." So we hang that next month in the museum lobby.
Do you get to go down for the final unveiling of your project?
Yeah, I'm sure. It's supposed to happen September 22nd of this year. Okay. So, yeah,
you got a little time.
Yeah, but awesome. I'm just fretting over getting this thing installed, and I'm gonna go down this week and check on if everything's ready. So there's no surprises next month.
Yeah,
right. Kind of.
Gosh, that's so crazy. That's so crazy. I mean, you've kind of had the gambit. And I mean, starting from, you kind of wanted to do the farming and like stay on that space. And then now from where you've been to where, the whole thing, what was your kind of draw to, the processes and like the lean, Six Sigma, all that stuff? What was kind of the fascination with that?
Well, that's a lot of the way a farm needs to run. You need to be thinking about, okay, I'm going to cut the hay this way because I have to be able to get the baler around and make all these corners, and I have to then be able to pick up the bales. So you're always thinking about
process,
right? Yeah, and planning all your work and looking more than just tomorrow, right? Whether it's cattle or crops or whatever. So I think that was inherent, and then I enjoy the design side too a lot, and I've always created a lot, but it's been more around machinery. Yeah. But a lot of times, like in the automotive, when we're launching new products and stuff, they would give us a clay model and said, "Here's the surface. You figure out how everything works behind it. Yeah. And here's where you have to interface." Yeah. So you're still engineering a lot, but you're given boundaries. Yeah. That's cool. And stuff. So, that was really fun. I've built oil rigs, solar power plants, rocket transporter for Blue Origin, rocket fuel tank welders for SpaceX and Blue Origin, all kinds of huge equipment, ag equipment and stuff like that. So it's been a full dirt closet to clean rooms in the process. Yeah.
That's awesome. Between kind of, you've worked with gigantic companies, medium-sized companies, small, startups, like all of them. What similarities have you kind of seen that they might all have similar problems with? Or is it different problems, just on a different, scale? Is it problems the big companies have, the only big companies have, and the smaller companies you can, what kind of are you seeing?
They're equal in all of them. Yeah. So many aren't process thinkers, and they don't use facts and data well. Yeah. There's some basic fundamentals, and then so I find expediters, people who like see a problem and just go firefight, get promoted. Yeah. And then they don't have much of a base, and it's the heroics of saving the day. Yeah. Versus, hey, where's the fundamental in an organization? So it always kind of goes back to people, and building a good team and teaching people to problem solve. And when I'd go in and do a lot of these turnarounds, the difficulty was, yes, there's one of the things we used at Delta Point is that they developed, and it came out of from a Japanese guy named Hirano, and but it really wasn't really clear in this stuff, but there's 8 steps of creating flow. And there's these fundamentals, and you kind of go through those. And when you go through those and lay down that foundation, your work becomes simpler and easier. Versus if you're not following flow, you're just responding to the next whack-a-mole.
Yeah.
Right? But if you create the flow, you get rid of 90% of the moles.
Mm-hmm.
So you're not having to whack-a-mole. Then it becomes much easier. Now we have the vital, what's left to problem solve. What's our common language? What kind of infrastructure have we built in the organization about what's the situation? What's our target for improvement? What's the proposal you're going to give me to go forward? Mm-hmm. Right? And just teaching job method improvement, or sometimes it's the Deming, people call it the Deming cycle, A3 thinking, PDCA, or it could be the Six Sigma Demic steps of those problem-solving steps. But so often the organization hasn't been taught that.
Yeah.
It doesn't have that foundation. And so it's really people aren't given the skills and built the knowledge for managing their daily work. They're not process thinkers.
Yeah.
Every process has 4 things always. And the Japanese called them the 4 M's. So you always have team members. You have materials. Materials can be the pieces and parts in a service business or an engineering office and the office type stuff. Materials equal data. And then you have a work method, you have a blueprint, you have a drawing, you have a standard operating procedure, some recipe to follow if you're a baker, mm-hmm. right? So that's the method. And a question, you follow the method, you ask a question of the data, it gives you information. And that's value that you're creating. And then the last one's machinery in the shop. It's the saw, the hammer, the building.
Yeah.
In an office, it's the computer hardware, it's the facility, mm-hmm. right? So the principles are still the same.
Yeah.
But it's like, so if something's not working, you don't understand your process. Yeah. Which of the 4 M's is failing? And you've heard of the term fishbone cause and effect diagram, right? Yeah, yeah. That's where most often the 4 M's get shown, mm-hmm. and trying to help people think through where the problem is and which to go solve. So it's just building an organization that has that common language, use some of those tools, but it's not about the tools. It's arming them with that so they can communicate faster and you know where you are, and you're ending up with better results and faster results than everybody just kind of making up their own thing. Yeah. You give them a little bit of structure and then you let them be creative within that.
Yeah. When you would go into, it doesn't really matter the size of the business, was there something or a group of things that you would always kind of check off first? You're like, all right, big picture, let's try to solve biggest problems. Was there commonalities between those? What was the checklist when you were going in first thing?
So usually I was there for some problem.
Yeah.
Right.
Okay. Yeah.
Delivery, quality, it was either delivery or quality.
Yeah.
And, so even when we were acquiring businesses, I'd always start at the same place. I want to go to the shipping dock and walk the floor backwards upstream. Mm-hmm. And I'm watching for what's there, how much inventory, what are people struggling with? Are there any quality indicators? Do I see a bunch of scrap, different things like that? Mm-hmm. People moving, forklifts moving around, baskets of stuff. Those are all highlight type problems that I look for. And then, so that's kind of part of that eight steps of creating flow. The loading dock is the closest point to the customer, right?
Yeah.
And if it's not, you don't get to count any of your work. That's a whole team in that factory, mm-hmm. or in that office. And if you aren't delivering that loan or that service to hospital patient or that order to that customer, that whole team failed, right?
Yeah.
And we have to make it the right time, the right quantity, right place, right? And then if you're doing all those things right, the price, you're going to be able to keep your price down because you don't have a lot of waste in your system.
Yeah.
So those, I would be watching for those and looking for the opportunities to flow. So often I'd walk into a place and they want to start me at the beginning. Here's the first step.
Mm-hmm.
I don't care.
Yeah.
And so often some manager, well, if we could just make this go faster, the first step, right? And I would look for piles of material through the shop, like raw materials sitting by a machine. And I'm like, so why is that one person sitting there making 5,000 parts a day when the next process can only use 30?
Yeah.
Right? Well, we have to optimize that machine.
Mm-hmm.
Yeah, you have shelves full of parts.
Yeah.
Right? That when you finally pull them out, you know, when did you make this? It's bad. Oh, 3 months ago. Well, what happened? Oh, let me look at the Traveler. Oh, Joe was sick that day. Bernie made those. He wasn't trained.
Yeah.
You know, spent all day making bad
Right.
parts. And then, now we need them.
Yeah.
And then, you know,
Crap.
right.
Yeah. That's so funny. That's great.
So those are some of they're really simple. It doesn't matter what you're doing, if it's a home loan or it's just make it and flow it through fast. And then if you're only allowing one piece as much as possible at each station, the waste of defects, you can catch them instantly and say, hey, you just did this. What's wrong with this spot here? Or, you know, get that quick feedback. Or, and everybody sees what needs to happen next, right? And you're not wasting all this time and money pushing around inventory in baskets. And when one of our first acquisitions, they came back in, oh, we want to buy a couple new forklifts. It's like, why?
Yeah.
Right? Let's just take that money and move all the machines together. And you don't need,
Yeah.
instead of buying something to move the parts
move it,
between the
right.
machines.
Yeah.
Right.
It's amazing to me that problem still exists of just like process. Because I mean, there's been countless books, documentary. I mean, there's so much resource out there.
They don't teach it in school. You know, you go to the engineering schools and they want the fundamentals of thermodynamics and strength of materials and gas laws and there's not very many operational courses.
Yeah.
More and more starting to shift those to the business schools.
Yeah. I took a couple of those. We read this book and it was called, I don't know who wrote it, but it was called The Goal. Have you read it?
Eli Goldratt. I read it in 1984.
Yeah. It still holds up. I read it when 3 years ago, 4 years ago.
So I'm a Jonah.
Okay.
I walk in and
your story reminded me of exactly that. It was the whole process of
the oven.
Starting. Yeah, exactly.
Well, we have
Why
to optimize that guy.
No, yeah.
Well, he has to go over and work over there.
Mm-hmm.
No, just put him in front of that oven. That's your bottleneck.
Right. Yeah.
That was so applicable. That novel, it was a great way to write and teach people to learn. You picked up the book and read right through it, right?
Yeah.
It was written in the Socratic method. It was a mystery. Is he going to get it? How's he going to?
I've never read a book for academic purposes like that like looped me in as much as it did. You know, it's usually like very cut and dry. Like this is this process and this is this procedure, and it's like it drones on. But then this one written as a mystery. It's like the whole time you're like, how is he? And you're learning about his home life, and you're just like tearing his hair out because he can't figure this out, and you're just like, what's going on? And then you get to the end of it, and he figures it out. But
that book is so applicable, and he ended up writing quite a few books through the years, and his son still runs his consulting. Fairchild is using Goldratt's principles. Basically, they have. Aircraft manufacturing plant out there, and they're applying the theories of constraint to their production scheduling and everything. I got a tour out there.
That's awesome.
One time to do a little innovation talk, and they showed me all the great stuff they're doing out at Fairchild. Really exciting to see.
That's awesome.
See that out there.
That's cool.
So, it's so Goldratt's so applicable, And it's a story about applying the principles of flow, and simplifying, and where do you put your efforts?
Yeah.
Yeah.
I feel like it's one of those things where almost hindsight is 2020, because when you solve it, when you figure it and you make it more streamlined, it's like, oh, obviously we should have done that. Move this here. It's like always very
So counterintuitive.
It's always very
though.
like maybe not simple, but like, oh, that makes sense. Of course.
So I can't remember how much he talked about it in the goal, but he had some basic principles, and this is really applicable to facilitating change. One of his first steps, and we did this at Delta Point really well, but he framed it, he said, evaporate the clouds. So we might be a team of people, and you say something one way, I say it another way, and we're missing.
Yeah.
We don't have an intersect point. So Delta Point was really good. The consulting firm was made up of a bunch of PhDs out of Oregon and UCLA and Berkeley, and they were organizational development, right? And so the first principle that when I walk in for anything is I want everybody to get on the same page.
Yeah.
And the Japanese talk about waste, and in the 30s, 40s, I think it was more, it might have been in the 50s, they came and visited Ford. Toyota had like one stamping plant, Ford had 50. And they started looking at all that, and then they go to the supermarkets, and Henry Ford had written a book, Today and Tomorrow, and they took a case of those home. And in that book, Henry Ford talks about just paying attention to waste. And the Japanese translate it all, and they come out with 7 deadly waste. Overproduction, waiting for something, and then waste of materials, defects. So waste of materials is like, maybe I have a 2x4, it needs to be 6 feet long. I buy them in 8 feet and I cut off.
Yeah.
Right.
Yeah.
Kind of dropping a lot of material. So it was all these principles, but because they needed to translate it, they came up with 7 definitions of waste. When in our culture, when we say waste, we just think trash.
Yeah.
Right. So we're not at this intersect point about talking about that. So that's one of the first things we do is get everybody together and say, here's some definitions of waste.
Yeah.
Let's talk through them and understand them. Does everybody understand them? Yeah. Great. Here's an assignment. We're going to break into 6 teams. We're going to break the plant into different areas. I want to get the floor plan, emergency exit floor plans, and each of your team trace where you're walking and go follow an order. Right. And then as you go to each station, see how much work is there, how many people are there, what's the cycle time, see what defects they might have occurring there, and identify any of these 7 wastes that you see there. And take pictures. When I first started, it was Polaroids.
That's awesome.
Right.
Going around.
And so they were given assignments, and it was usually a mix of shop floor people and the executives, put them together.
Yeah.
So they get in a mix and they go off. And then they come back, and we give them some time to summarize. Like, give us a summary of everything you learned. And so basically they just audited their own company.
Yeah.
And hey, I had this part. It took 8 weeks to travel through the shop if it,
Hits
goes
all
through
the
it.
points. Yeah.
And it traveled 3 miles, and there was this much inventory piled up all over, and this many people touched it. So, and then here are examples of waste, and they're pretty down, right? But I didn't have to tell them. They found it themselves.
Yeah.
So we evaporated the cloud by having a common language of waste. I gave them an assignment to go find it. So I could have done the audit and written a report and handed it to them, and they would have, pushed. No.
Right.
But they come back in, so I've already won. That was Gold Rat's second principle: is evaporate the cloud and then let them find. Don't use judo, right? Kind of move where it's their momentum and energy. So that's then they want to change. You create creative tension. I run some exercises about creating flow in the 8 steps and how to apply them with paper airplanes, and everybody does it. They touched it and they did it themselves, and we summarize the numbers, and it's like, you guys had a 75% faster throughput with the paper airplanes the second way, following the 8 steps. You had 90% less inventory. You had 4 or 5 times the productivity gain. Like, who doesn't want to go do this? Everybody wants to do it, right? So that's the creative tension. I gave them a vision of where they could go and creating that target. So then they now go build your proposal of where you want to go in your company. So many of the managers, when I'd get there, they go, oh, we need to work that first upstream.
Mm-hmm.
I can't get my raw material through fast. No, it's downstream at the customer and at the shipping dock, and let's work our way back. So that was a typical, doesn't matter if it was a consulting gig, or a startup, or just one of the private equity investments. Yeah, it was applicable to everybody.
Yeah, was that fun for you to go and do, or did it get kind of?
It would no. It was.
You go and you're like, guys, it's the same problem every time.
It was fun to see what the challenge was. Sometimes there's little subtleties. Yeah. But in general, I'd follow these basic rules, these 8 steps of flow. That was the sword I'd fall on. If I just stuck to those principles, I will uncover the problem.
Yeah.
Right.
Yeah.
We will find it and solve it and make it better.
Yeah.
Right.
And then when you're looking, because you said you kind of transitioned and switched, and then you were looking at acquiring a business, and then did acquire 5. What was that process? I mean, were you looking at processes when you're looking at different businesses to buy? I mean, what type of business? What are you looking for? Because that's a kind of a big, at least for me. I mean, I'm around it a lot, but it seems like that's kind of bubbling up, and it's getting more popular. People are getting more interested in the whole search fund, business entrepreneurship through acquisition.
Right. There seems to be a lot of that going on in Spokane. I started that back in, 20 plus years ago. I focused on manufacturing. Okay. That's what I didn't want a service business or anything about that, because that's the space I knew. When I talked about, often people give me referrals as someone's moving into the area, somebody, like maybe a doctor's moving in, their spouse is coming, or, there's some, I get these referrals and they go, well, I was an engineer, or I have my MBA, and, I think I want to go buy an engineering firm. I'm like, well, have you worked in one? No, I was in medical stuff. Mm-hmm. Do you have a client list? So one of the best things about, I think one of the most important things, let me correct that statement, is if you're looking at buying something, I think you should have a body of knowledge around it. Yeah. And I have a pretty broad experience base, but I think knowing that very specific channel, the more time you have spent in it, it helps. I was doing a bunch of stamping, heavy metal stamping in Ohio is one of the businesses, truck parts and stuff like that. And knowing that space, knowing the players, knowing the technology, I think that helps. I picked it up fast and learned fast. And I try to reflect after each acquisition or each engagement or investment. And I've done angel investing and startups, just reflecting out what's working, what didn't work. Like some of these more industrial places, they would just kind of wait for the back. Do you know what a fax machine is?
I do know what a fax machine is. I've never used one, but I do know what it is. You've heard the term? I've heard the term. I don't think I could figure out how to do it, but I've never faxed anything.
You would just do it it's called email now.
Oh, just email it. Yeah. Yeah. But yes, I'm familiar.
Right. So I would call it fax sales. They would just look at the fax machine. Did we get a PO? Right. They had the customer base and some of that kind of stuff was kind of interesting about that industry. So there's a lot of different challenges, but all of them had operational things when I talked about creating flow. So if they weren't flowing, if they weren't doing lean, I knew I could probably free up a lot of working capital right away because it's tied up in inventory.
Yeah.
It's not the traditional, oh, it's just in time, we're going to cut all the inventory. No, there's a beginning of the process and an end of the process. In the beginning of the process, I always want to make sure I have all my raw materials there when I start it, and I don't want to cut short, and I will keep extra inventory based upon managing a plan for every part, looking at the lead times, quantities ordered, best price, stuff like that, and knowing what product's being built.
Yeah.
But in between the walls, work in process, I want to keep it lean and flowing and as much one piece as possible. Sometimes there's an oven or long cure time. That's fine to have 100 pieces. Maybe something goes in the oven every minute, and it's 100-minute cure time, and I'm pulling something out of the oven. So how do I create a carousel so it's automatically coming out or something like that? So it's flowing, and there's minimal. It's always one less and flowing, and I can probably blow out 90% of their working capital and work in process inventory and free up a lot of cash. That was one thing. Right away you can do that, and then it's like I'd rather take that money and go buy more machines.
Yeah.
Or something to make the demands there and stuff. And through the acquisition process, it's those fundamentals are always there. And I think it's stick to an industry because that's going to give you a jump. The second thing is knowing the customers is really important. So when we'd go in and I'd look at the customers. What is the customer base? How diverse is it?
Right.
Are you getting 80% of the sales out of 20% of the customers? Maybe that's good. Maybe, because now I see how do we go open up what other things can we be selling?
Yeah. Don't want to lose one customer and lose half your yearly revenue.
Right.
Awesome.
But I've worked with a few people that's happened, and they've been really good. That's their strength is sales.
Yeah.
And they were in machining, and they were able to go fill in as industry changed, telecom, medical. They just understood the sales process and were able to process and fill, before the year was up, be able to make it up. And that's really unique in most of the businesses is the sales. And sometimes when you're looking at businesses, I got taken into one quite a few times, and it was kind of a process industry. So it had all these big furnaces, and if you turn on the furnaces, you better have full loads. Mm-hmm. So they're like, what process improvements can you do? I'd say, we need to work on the sales process.
Yeah.
Right? Because if we shouldn't be worrying about this stuff until I got the orders, right?
Yeah.
And we can feed them.
Yeah.
Kind of thing. So
totally makes sense.
So I like manufacturing its pieces and parts. It can be really difficult in food ingredients, the commodity, the prices jump, milk, flour, sugar, they're very volatile. Yeah. Where steel, it moves. I've seen it move pretty big a few times. So that's always a challenge. You're faced with your raw materials and stuff like that. And there's periods where they're more stable, and there's periods where they're crazy in the process. But yeah, it seems like there's a lot of people, like you said, doing search funds and looking. But you need operators, and that's where I had 4 Harvard MBA guys I worked with, and three of them. One was my partner, and he came out of Caltech, and we worked. But the other 3 were with our equity partners and stuff. And they ended up seeing the operational stuff I was doing and said, well, we have this other business we bought over here. Can you go do that over there? Can you go do this? Yeah. So often I'm in Fergus Falls, Minnesota, Phoenix, Pittsburgh, Pennsylvania, Scranton, Pennsylvania. Applying these same operational
Yeah.
Kind of principles. And it wasn't just, process focused or shop focused. It was also looking at the product. One of the companies made some document binding equipment, and the Chinese were dumping onto the market big time. And so we had to do a value analysis of everything was in there. And it's like, why'd they put that screw there? Why is there 4 different screw sizes used? And it was the machinist making the prototype, whatever he had there on his bench, that's what he did. And then the engineer just made the bill of materials and copied it out.
Do that, exactly.
And it's like we stripped all that out.
That's crazy.
And took out 50%. That became the corporate goal.
Yeah.
Was every new product, every time we touched a product, how could we take out 50% of the cost by value engineering it?
Yeah.
And then do some design for manufacturability and things like that. Could we snap the cover on versus 12 screws?
Yeah.
We cut a ton. They were machining parts out of Delrin. It's a hard plastic. They needed some little pieces, and the volume was so low. They go, we went to the injection molding guys in town, and they wouldn't touch it because the volume was so low. Well, they're used to molding for Scott goggles,
Right.
kind of thing, bazillion. And it's like, but I knew a shop here in Spokane. I brought that stuff back, and they go, we can do that for like $5,000, make a tool with all, and then we'll do a, run twice a year, and we can adjust each time. And all the machining time I saved in the raw material, we cut 90% of the cost out of that. It paid for itself the first run on the tools, because all of a sudden we freed up a mill to go make the metal parts,
right?
And stuff. So I think it's really important to have a body of knowledge.
Yeah.
Of what you're managing if you're going to go buy it.
I feel like
or bring people in.
Yeah, there's so much, like I said, it's getting talked about more and more and more, but I feel like the knowledge base of there's people out there that want to go buy, I don't know, like a service business. They want to go buy like a roofing company or a siding company, whatever, but have never worked. They've never done it before. Like, how hard could it be? Which like, okay, I guess, but there's that subsect of people too that just want to do it because it's like, kind of quick and easy route to go own your own business and operate, maybe not even operate, because there's a lot of, kind of the other side of people want to go buy a business, but then not operate. They want to find an operator, and it's like, well, and there's a lot of things where it can go right. There's a lot of stuff where it can definitely go wrong as well.
That's, the restaurant business or whatever.
Yeah.
I've done a lot of coaching, and people go, I want to do this food product or this, that. Well, I want to do a smoothie company. Have you worked in the restaurant industry? No. What are you going to offer, right?
Yeah.
Why don't you start with a cart instead of renting a building? Go to that street market, go to the farmer's market and see if people are buying. The risk is pretty low.
Yeah.
Right.
Yeah.
Kinda
Seriously.
Try to manage it. And,
yeah. So then going from that to then working with Skywalker Ranch, you said it was interesting, a little bit more of a project. What about that particular job and experience was more interesting than the rest of the stuff that you did?
Well, this one really, we had a tight timeline. So my boss basically just said, don't miss the delivery schedule. But they couldn't tell me a delivery schedule.
Don't miss it. We're not going to tell you when it is, but don't miss it.
But you're already late.
We needed it a week ago.
Right. And I go out to the building in LA, and it's just a concrete slab on the ground, right? The parking garage is in with nothing. But I'm the critical path.
Yeah.
My panels are holding up. What steel?
Yeah.
But then the project plans and stuff, they just didn't feel that contractor was delivering. And so Skywalker stepped in and licensed the technology and took them over. So I had kind of this unique role. Basically, it was a startup.
Yeah.
With somebody had a technology idea, and then I needed to make it all work, right?
Yeah.
And so there was a crew of good engineers already. There was 20 people when I got there, and everything had been undersized, and I needed to tool up 150,000 square feet of building I needed to put proper, thinking of the 4Ms, the buildings didn't have HVAC. This is a chemical process. We need stable temperatures, so good HVAC units. We needed better process equipment. So we spent about $8 million on machinery.
Yeah.
Yeah. And my boss would remind me weekly that I'm spending too much money, but don't miss a delivery. And I think he had been sold by other people that it was much further along than it was.
Yeah.
And so I just had to constantly lay out and communicate, this is why I'm buying these 3 60-foot 5-axis mills to cut these 500 square foot parts.
Yeah.
There's 1,271 uniquely shaped panels on this building, and each one is its own shape. So it's the same as the 50 top boat manufacturers in the world, each having to cut 30 new boat hull designs in 36 months. And then we had finishing details we had to figure out. I had to sit down, spend a lot of time with the architect. There'd been a mock-up made, a 9-panel mock-up. So my boss and the executive architect didn't like it. So I sat with the architect and we kind of figured, we talked about each feature, and then I had to codify, and he couldn't even say, he would just point at something and this is kind of, I like, and through that I wrote this 13-page workmanship standard, and we built another 9-panel mock-up and sent it down to replace it. And my boss goes, I love it. Just tell everybody in the shop to make it like this. I'll sign it and just tell them to make it like this. And it's well, no, there's a lot of subtlety here that we've defined for the workers now. They understand this characteristic and why we have to control it. And it wasn't written in the spec. And so there was a lot of that development work, process development work on the finishes, how to put the gel coat down, the cure times, the vacuum pressures when we laid up the glass and the resins, training. There wasn't a training program, and I've hired 100 welders, and they all came with AWS certification, and I could test them, and we would destructive test and say, yeah, you can make the basic weld, we'll hire you, and we can see if you can do the rest of the stuff. But there was nothing like this. We were just hiring. It's COVID. We're hiring people off the street. We had to double the wages almost because the company wasn't hardly paying anything, and I was trying to, I kind of drew a 40-minute commute circle around the plant and hired a woman who'd worked for me before to go scour LinkedIn pages and find employees. And did they have 5 years of industrial work experience? We'll hire you.
Yeah, that was it.
If they're working for 5 years, it tells me they show up for work probably.
Yeah, that's true.
And stuff. And so we ended up hiring 240 people.
Oh my gosh.
It churned through a lot more than that.
In the span of how many months? What was that total?
About 18 months.
Jeez. Yeah.
Right. And
that's got to be tough with mesh too.
Right.
If you're working on a big project, everyone's got to be on the
so
same
we did
page.
a lot of training, basic training. We had this whole training certification program. I had a really good chemical engineer, and I just point him in the right direction and give him the context. And I said, hey, I used to have welders. They had AWS test. I said, do a 3x3 panel, put the hardest features in it, have them roll out the glass. We'll cut it, cure it, cut it in half, no voids. He goes, I got it. I get where you're going. And we created this whole program to train people so they had 3 chances to learn how to properly laminate and make a good part.
Yeah.
Right.
Jeez.
So that was, it's just one thing after another like that.
Yeah.
Then there were measurement methods. They weren't measuring the parts correctly. Plastic, fiberglass, composites can be very flexible but very strong. They're not rigid, and people don't understand that. And sometimes designers are too stuck in the metaverse, or a lot of errors can happen in the metaverse when designing a part. So what happened was we do all this finite element analysis of the structure to see where things are strong enough or not strong. And we had to meet wind load and seismic requirements. It's, Los Angeles.
Right.
The whole building can slide 36 inches in any direction.
Jeez.
This ginormous building on
That's
these pads
crazy.
and stuff. But there's still these other seismic things. And so this world-class composite, he works for everybody designing America Cup boats.
Mm-hmm.
And he travels all over the world. And he's brilliant, but the problem was he would just go on what some boundaries people would say, right? And he had done from where the T-pin bonded onto the back of the panel and the T-pin came up and got clamped, bolted onto this beam. Mm-hmm. And he just looked back to the edge of the beam and stopped in his analysis, and we needed to really look at the whole steel structure, tertiary steel structure. So it's like, Kurt, I want you to look at this. And he's like, really? They wouldn't pay me or ask me that the smaller company didn't want to spend the money. I said, nope, go do it, run them all. and so he went back through and we modeled the whole thing and found the points that were most difficult, but also in that process we began to understand the edge of the panel was the most critical, and the measurement, people weren't measuring it right, and they were like splitting hairs over 50,000th dimple on the way out in the center of the panel, and it was so curved and moved you would have never even seen it.
Yeah.
When the most critical was the edge where everything mated.
Yeah.
And so that's what we wanted to simulate. So we started going through that, and that engineering work took about 18 months to unravel all that, both the other supplier and our crew going panel by panel and working through. So at the same time, we're trying to build the factory, get up to speed, train people. We're taking some of the easier ones, running them through. So we're doing production, but it is all very fluid and dynamic and in the whole process.
Yeah, I mean, for like such a building like that, where everything is so custom, I mean, everything. I mean, it's got to be impossible to be like, let's get all on the same page. I mean, you kind of can't even get a whole processes and procedures for.
That's where I think all the contractors involved until I got there didn't grasp that every frame, every panel was different, and it needed to be addressed on its own. And where you look up the side of the building, it's just big plates, flat windows, right? But each one of these was start over, right? So that was, and it was so unique in the process. So we built a really good team of people. It took a while. We spent a lot of time on training, getting them up to speed, putting in basic fundamentals of how a shop should run, try to teach them to be process thinkers, help the first level supervisors, teaching them how to teach, teaching them how to improve work, teaching them about job relations. It was a big effort, and I was fortunate I had some really sharp engineers and stuff. They just needed some guidance.
Yeah. That's awesome. Gosh. And then we haven't even talked about your new project now, which we'll get into, but now you're working on something completely different.
Kinda, yeah. So I've taken the CEO position of alternative energy materials.
Yeah.
And while I was right before COVID, I had built a prototype grain drill for Franklin County for Franklin County Conservation District. They're under a lot of pressure to manage erosion, and the equipment is old, and they wanted some help. So I had a prototype project, and I spent a lot of time out with the farmers, and I started to see some emerging patterns of things, how John Deere, Case, Internet, IH, they're not really providing solutions to farmers in our region. There's a lot more money in corn and soybeans in the Midwest, and that's where they put their focus. So, and then I did a big economic study, and the medium age was like 65.
Yeah.
So, you want me to go buy a new $350,000 grain drill?
Yeah,
the
forget it. I'm retiring in 2 years.
Yeah, and my grandfather paid $20,000 for that.
Yeah.
Right.
Yeah.
I'm still using it. What's your favorite? The one I'm pulling.
Yeah, exactly.
So I started thinking about what do they really need and what's their future, and I did a little I wrote some papers on it, and then a few of the farm groups asked me to go talk about it, and then I thought, well, I'll make it into a TED Talk.
Nice.
And it's a smaller, simpler tractor, so it doesn't matter what size your farm is. Okay, you can go buy 3 of these autonomous bots, and they can run 24/7 kind of thing. Versus you have a big farm, go buy 100 of them.
Yeah.
Right, and they're each independent. So if one breaks, the rest are still running. Right, kind of thing. And so I was poking at that, and then at the same time, it's all about soil. So I'm really fascinated by soil structure and microbiology and nutrients and stuff like that. So I was spending a lot of time researching that. And then on our farm, we have a lot of wind power.
Oh, a lot of turbines.
Yeah, a lot. We down in Columbia County, Dayton, Washington, has the top wind in the country.
Yeah.
It's just steady as she blows.
Yeah. You kind of hit that point driving from Spokane to Seattle, kind of right in the middle there, where all of a sudden you just start seeing hundreds of those turbines pop up, and they're always spinning.
So
constantly.
Ours are down along the Snake on the Blues there. And there's a plateau in there, and it's just like the top rated wind in the country. It's not like everyone knows the gorge is windy, but it can be more gusty there because it's a vortex.
Right.
So ours is just steady. And I was thinking, there's a lot of things going on. Fertilizer keeps going up for us every year. We're a huge user of anhydrous ammonia. I'm like, well, I should just get windmill and then build out. Anhydrous ammonia was originally invented in 1910 by Haber and Bosch, the German chemist.
Yeah.
And it's a electrolysis process, and it, air is 80% nitrogen or something like that, and water is hydrogen and O2, and so you can, through electrolysis, extract the hydrogen from the water, and through electrolysis, you can extract the nitrogen, and you cook them, and you get NH3. And it's 4 times the density of hydrogen by itself. And the beauty of anhydrous ammonia, it can be stored at 120 psi, where hydrogen by itself has to be like 3,000 psi. So it stores really well. It's a better carrier of hydrogen, and there's some real benefits. But we also use that as fertilizer. That's why it was invented. So we're at this interesting point, just like back in about the early 1900s. And I wrote an article and posted on LinkedIn. I don't know if you saw it.
About the future of farming, 2050?
No, there's a new one. I posted last week about so oil was about kerosene when it came on. Standard Oil started because it was a kerosene lantern oil company, and gas was waste in like 1870.
Yeah.
and in that time period, and and then there was a shift right in the marketplace, and then Edison did electricity in the 1800s, and then Ford gets the Model T going, and then it's like, so it was easy for Standard Oil. The oil companies were in place. They had abundance of fuel, but they didn't know where to go with it, and so they were able to just slide in, fill in. And gas is a good storage. Petroleum-based, carbon-based fuels, why they've been so well adapted to our society, because a piece of coal or oil is stored energy, right? And now more stuff runs on electricity and stuff, and we're facing these new challenges. And so back to alternative energy materials. It's a company founded, the patents and stuff came from out of WSU with the professor, Dustin McLarty. And he'd been working on this clean coal initially kind of thing, and then that kind of brushed. And through the process of the hydrogen economy started working up, and he just realized along the way, anhydrous is better than hydrogen itself. It's easier to handle. We can put it in pipelines like the natural gas lines, and we can produce it. But one of the problems with producing green anhydrous, like I was going to do, is it's more expensive. Well, for me, if I would have put up my own wind tower and my own electrolysis plant, I was looking at some out of Europe, I wouldn't have been off the grid, so I wouldn't have had to pay all these extra fees, right? So I could have had pretty low cost power and just made mine, and it would have been more stable fertilizer price for us on our farm than what we could buy, because anhydrous today is not made with electricity, it's made with natural gas. So it has a big carbon CO2 footprint, and it's the second most produced chemical in the world. So there's an infrastructure for it already. In the U.S., it's a $20 billion market, and 80% of that is fertilizer. And then they use it as a refrigerant in big cold storage places and some other uses for ammonia. And then globally, it's about 100 million. So it's a big deal, and but it's tied to natural gas prices. So our inland Northwest farmers have just been clobbered since the Ukrainian war. Prices, their retail price per ton jumped from like $750 a ton to $1,700 a ton in a year.
Yikes.
And crop prices, the bottom fell out because of the war, because then the Russians and Ukrainians were dumping all their wheat on the world market. So $10 wheat drops to $6, and their fertilizer cost is their most variable, and the highest cost shot up. So there's a lot of farmers hurting.
It's not a great combination.
Right. So I was about 3 years ago, someone said, Dustin's talking the same way you were. You two should talk. So on one of my trips down to the farm, I pull into Pullman and we meet, and he's going, I'm working on this. I'm bootstrapping. I've got all this test stuff I'm building, but I also have to build the test equipment to test it. And it's like making a dyno for testing the horsepower on a car or something, and nobody else had this stuff at his price. So all these universities, labs, and other hydrogen startups wanted his equipment. So he says, I'm selling $800,000, $900,000 of this stuff a year. And now I'm funding my, I got 10 engineers working here. And so, that's cool. And I got this big project I'm working at Lucas. And so then he called me at Thanksgiving and he said, well, how's that project coming? I said, well, I'm just about ready to finish up. And he said, well, all my funding dried up. When he was at the university, he had secured about $6 million worth of work. So he's done a lot of work through different grants and stuff. And he was trying for another grant, $2 million through the Department of Energy. That got cut at January.
It's a common story. There's a lot of people that got affected by that.
And then all these people buying his test equipment got their budgets cut. So they said, we love your test stuff, but we have to preserve the money we have. We have to cancel those orders. So he said, oops, it's time to do something new. And Springboard was helping coach him, Steve Neff, and doing a great job. And I don't know exactly what Neff and
Tim Cross or Bill Kalibas.
Well, Bill, all those. Launchpad Northwest, and I think Steve was on the point. But I think Steve gave him coaching probably something like, it's you can't just be a sole founder. Everyone's always looking for two people. Right. And so that's why he, I guess, realized, well, I need somebody. And Chris was he scaled stuff. So he asked me to come on board, and I've been looking under the hood, and I thought his science, like He's got patents pending. He spent a lot of his career working on this, so it's just not the first time.
Right.
So the little things I'm looking for, like, hey, have you worked in that industry before?
Yeah.
Have you built that before?
Right.
And so I'm trying to reflect on a lot of the things I've learned through the years, and I'm going, okay, check. Is it risky? Yes. Have I had have I finished a project that was really hard, but I had a paycheck? Now I'm shifting, but it's really exciting. I like how he approaches it. We already were in sync on that. So I've dove into the process, understanding his technology better and the elements of it, and understanding the market. I understand it much better now when I started sharing you those numbers.
Yeah.
So I started asking, where else can we use this? I know it works as a refrigerant already. And as a refrigerant, there's a couple different ways of refrigerating something. In the ones we know, we plug it in,
Yep.
right? And that's called a refrigerator, right? And the little pump pumps the refrigerant up to pressure, and that flashes across evaporator, and then as the air comes across that evaporator, the heat gets drawn out, and it produces cool air, right? And then it goes back to this high pressure to low pressure. That pressure drop, like cold air out of an air compressor, feels cool. You get that. That's the process. And then as it comes back, you condense it and repump it. Well, you don't have to do that with electricity necessarily. You can do that with heat. The old propane refrigerators, everyone's cabins and stuff like that, they were propane. So you could just boil it to get your high pressure instead of pumping it, right? So I've always been excited about that, and I thought that's an interesting technology because I'd run my combine engine up to 2,300 RPM, and it's hydrostatic drive, and at the time it was 150 horsepower, and 2/3 of the energy is going out in heat. And I always thought, well, I could put a refrigerant on there, boil it, and have it go across the turbine and spin, make a little extra electricity. And where could I use that? So I've always liked this since engineering school. So this all fits in that same thing. It's like, where else can we use the anhydrous? The beauty is we have a customer right away. If we put up a solar plant or a wind turbine, farmers will buy it. The infrastructure is already there. They've been using it for 60 years in their wheat fields to fertilize. It's a great fertilizer chemical. Yeah. And so it's already used. The infrastructure is there. People know how to handle it safely. It's not explosive. People think, oh, fertilizer explosive. No, not this type. Yeah. It's really hard to get anhydrous to explode. You need a like igniter, like you need to put another fuel in it and light that fuel then.
Okay. Yeah. So safer.
Yeah. Where hydrogen will go kaboom.
Right.
So it's kind of like if you're trying to light gasoline, it goes kaboom. You try to light diesel with a match, it just won't light, right? Yeah. It's kind of the same way between hydrogen and anhydrous. Yeah. A little bit. But diesel even explodes easier than anhydrous does. We were excited about providing farmers with green anhydrous, but we realized they don't care if it's green. They just want a good price. Right. And Dustin's system can produce it cheaper or on par with the natural gas. Yeah. And so far, everybody doing green anhydrous hasn't been able to beat natural gas prices. So it required some subsidies and things like that. So he has a breakthrough with a cheaper system, which is really exciting. And it's, but then we started looking at it. It's like, well, it's a round trip system too. Mm-hmm. So it's a fuel cell. It produces anhydrous, and then you can run it back through and it'll produce electricity. Reverse, a full cycle. So it stores so well and so easy. I can just put it in the tank and leave it there for months on end. You know, and if you see a rail car like propane tank, rail cars haul 100 to 110 tons, and so that's a 100-ton tank, and they usually call that just a bullet. Yeah, big, but you've seen, the propane tanks at propane companies, the big ones, or on the trucks, right? The semi carries about a 34-ton tank. The big bullet's about 100 ton. So you can take 2 of those 100-ton tanks, put it on our system. It's a 2.5 megawatt. It's a shipping container, little 20-foot shipping container. And it can run for 360 hours off those 2 tanks.
Jeez.
So that's 900 megawatt hours. And the power, it's like equivalent horsepower is over 3,300 horsepower. So that's like if I set a car engine there or a turbine engine, that's the horsepower this would be making at 2.5 megawatts is that equivalent. So it's all of a sudden, well, this is interesting. What else should we be doing with it? And so we think it's a revolutionary tool to stabilize the grid. So the grid is changing very quickly.
Yeah, it's also another popular topic of conversation. Everyone's worried about what's going to happen with the grid, with electric cars, and now with AI and data centers and all that.
Grid used to just be wires.
Yeah.
And it used to be about speed of getting power places. And now what we're proposing and shifting to is how do we allow the grid to move from managing molecules, managing a commodity. So our product will offer them absorption of energy. Where up until now, it's just about pushing energy around, but there's no storage. And so now we can drop these units on every substation and give utilities all this power, for natural disasters. Hey, there's an ice storm, all these lines fell down. Well, we'll turn on this and they can still get power over here. Or there's a fire, wildfire. We'll turn off that and you still have power. Or it's just a high load. Hey, we can turn this on and then you can put the load elsewhere, right? Yeah. This is covered. So that's an incredible amount of power. That system is about $15 million. It seems like a lot of money. The equivalent in battery, a lithium battery, would be like 40 to 60 million if you could even. A lithium battery, you get 4 hours of power. You just need more cells.
Right. Yeah, just keep stacking them. Yeah, which I did not know. Someone was telling me that the other day. It was like if you look at I guess the best example or the most easiest one to quantify is the Tesla battery.
Right.
It's not just one giant battery. It's it's all these little cells that are just stacked up together and they're just put in one thing. I had no idea.
Yeah, it's all the cells stacked in there. And so if you want more, you need to go buy all these expensive cells. For us, it's like 30 cents a kilowatt cost of a tank. The tanks are so cheap. We just go drop another tank there.
Yeah.
Small footprint, a tenth of this footprint.
Yeah.
And then rows and rows of batteries that burn up. Exactly. They're so flammable.
Yeah.
They torch off.
Right.
There's been several problems with that already. When the fire departments just watch it burn for weeks.
Yeah.
They can't put it out.
Yeah.
And then there's the contaminated soil. And we have people coming to us on our farm because we have so much wind. And we're right on the main grid, transmission interconnects. They go, oh, we want to put in a battery farm. We need 40 acres. Will you rent it to us? We said, no, we'll sell it to you because we don't want the chemical liability.
Yeah.
Right. But we won't sell it to you for farmland price. We'll sell it to you for industrial.
Yeah. Yeah.
But this is a solution. The state of Washington has 65 utilities. Our state could become the most hardened grid in the country. Our farmers in Washington State, I pulled this off Washington State Department of Agriculture, our anhydrous, all of our chemicals used have to be recorded with the state in ag.
Yeah.
And so I was able to extract this data out, and we use annually about 263,000 tons of anhydrous.
Jeez.
Right.
And if you're making it at, green, making it cheaper.
That both.
Right.
So we can we can make it for less than wholesale price of natural gas right now by about 30%. And then that carbon produced from burning all that natural gas to make that 600,000 tons of CO2. So we can be zero emissions. But so this would be one asset, 3 solutions.
Yeah.
Huge reduction on CO2 produced. The thing is, it's not made here. It's all imported. Anhydrous is brought out of Canada because Canadians have cheap natural gas, and so it comes in on rail and delivered into Washington State. But it's still eliminating that CO2. Then the second thing is we make it, if we're sprinkled around the state, it's distributed, grid, hardens our grid, gives power companies an energy storage system they've never had in their grid, and much more reliable than batteries, because now I have that duration. And I can play with my tank sizes. All of a sudden, somebody's having a problem. I just bring a trailer from another site and drop it there if they need the extra. It's so portable, right? So it's a grid hardening tool, energy storage for utilities. It eliminates the CO2 problem out of fertilizer, and it gives our growers, it takes them off the global commodity price of anhydrous and gives them a fair price that they can budget every year, and helps our community with ag. So it's really exciting as we're moving through this and figuring it all out. But that's where we're focusing right now in this process.
That's fantastic. So. God, what an interesting, life, career, everything. That's just awesome. That's so cool. And I'm excited to see where this goes. I've met Dustin, obviously, and then I know you. Seems like a great team. You guys have a bright future ahead. I'm excited to see where that goes.
I'm not. We have a lot of hard work.
Oh yeah,
we have a lot of hard work.
Oh yeah.
So we're pretty realistic about that, but it's exciting. We see the light where we need to go, and it's about executing.
That's awesome.
And that's the stuff I like to do.
I love it.
That's been my career of get her done,
getting stuff done. I love it. All right. Well, any parting words before we kind of wrap this up here? Any advice? Words of wisdom you want to drop on there? Anything we didn't touch on that you want to make sure we get in here? We covered a lot. God, we got the gambit. It's a masterclass in operational specialty and anhydrous.
Yeah, I'd say, a couple of things. Your most key assets are your people, right? Your team members, and so giving them the right skills and stuff. And it drove me nuts early on in my career. Executive would come in and say, "Oh, you're all empowered," and then walk out. Mm-hmm. You have to give people boundaries, and those boundaries aren't constraints, but you define work for them, and you define how to communicate. You build that infrastructure, and then you let them excel within that. Then you can say, you're empowered.
Yeah.
So that's building a great infrastructure around your people is key in the process, and use facts and data. I don't want to argue about opinions.
Yeah. Can't argue with the facts.
Right.
Or the data.
That's always so helpful to grasp the story. Just process thinking and people and use facts and data.
Yeah, that's awesome. Well, cool. Where can people reach out to you? Where can people find you? You guys have a website for the new business. Yeah,
we're in the process of thinking about our name, what's more suiting.
Yeah.
So it's energymaterials.com is our webpage. I can be reached at chris.wood@drylandsa.com. That's my email. Or they can reach out to you.
Really, reach out to me. I'll get you. I'll be your first wall of defense for all the fans that'll be coming in.
No fans here. All the people laughing.
I love it. Okay. Well, Chris, thank you so much for coming on. Really appreciate you sharing your story.
Thank you.
Awesome. Thanks.